The Initiative in Innovative Computing at Harvard, or IIC, was founded in 2005 to develop new approaches for advancing computational capabilities in the sciences and to disseminate its findings to the academic community, to industry, and to the general public.
One of the chief functions of the IIC is to foster collaborative research projects that address fundamental challenges to collecting, analyzing, and sharing the vast amounts of data now available to today's scientists. Astronomical Medicine is a pilot project of the IIC. The project's objective is to address research and computational problems that are common to both astronomy and medicine, such as data visualization, image analysis, and the intuitive exploration and display of complex structures. For over 15 years, the Surgical Planning Lab at Brigham and Women's Hospital in Boston has been building software for analyzing and visualizing medical data. These tools, such as the 3D slicer visualization application, have been used both inside and outside the operating room to treat patients and understand disease. For clinical applications, three-dimensional images of the brain are obtained from a CT or MRI scanner. These images take the form of slices, two-dimensional cross-sections of the patient's body.
Slicer combines these medical images into a volume of data, extracts the structures important to the doctor, and displays them in an interactive user interface. A physician can better understand the relationship between a patient's anatomy and disease structures, say a tumor, by studying these geometric models together with cross-sections of the original scan data.
To pave the way for future discoveries, the IIC is collaborating with the scientists who developed 3D Slicer and other medical visualization software to adapt the medical imaging tools so that they can be used in many other areas of science, including astronomy. Although their field of science is very different, astronomers actually study data very similar to that used in medical imaging. Data may come from traditional optical instruments or from telescopes that observe at wavelengths humans cannot see. Much of the data used in the IIC project comes from sensitive radio telescopes that capture spectral information from every point in a specific region of the sky.
Most astronomy data is 2D, pictures of the sky at different wavelengths and magnifications. Even though we can't see the actual 3D structure of the clouds, how fast bits of material in these clouds are moving toward us or away from us can be determined with great precision. In effect, this Doppler shift adds a third dimension to our data: velocity. Areas of interest, such as the turbulent star-forming regions in the constellation Perseus, contain many sections that have different velocities compared to Earth. One way of visualizing this is to create a series of slices, 2D images at each given velocity, where the brightness of every pixel represents the gas emissions intensity. This method is commonly used in astronomy today.
Viewing the data as separate images is difficult to interpret. Even trained astronomers have trouble identifying all the features revealed in large, complex data sets. Using the medical imaging software to import and process this data, surfaces of similar values stand out clearly, giving a hint of the underlying structure.
This 3D visualization allows me to better view the inner dense regions and velocity structure of the gas. We have been able to identify dozens of jets, a large bubble or shell, and many smaller shells and voids in the cloud structure. Work that might have taken months using traditional methods only took hours with this software. Some of the features we identified would likely never have been uncovered without the 3D visualization.
The IIC is helping scientists better understand their data and make new discoveries by continuing to enhance 3D Slicer and other visualization tools. But the IIC's work is just beginning. By bridging fields like astronomy and medicine through computer science, and by providing experts from different disciplines with the tools they need to innovate and collaborate, the IIC hopes to change how science is done, accelerating the process of discovery today and in the future.